Have you ever wanted to just sit down and run a few site scenarios on your own, like laying out a site plan or testing an access road without waiting on drafters or GIS to send something back? Well, I've been there too. And if you've tried following tutorials online on road design, you've probably noticed they can feel clunky and not very realistic for actual engineering work. So in this video, I'm going to show you 2 ways how not to build a road. Then I'll show you the correct way, how to build it properly, calculate grade volumes, and test different scenarios before you commit to a design. I'll even give you a simple macro code you can run with a single click, even if you've never touched the macro before. So let's dive in. First things first, I'm going to start with this terrain. I've already loaded the DEM for this site, and this is what we'll use as the base surface for the road alignment. Now, the objective is simple. Build a road from this point to this point. And here's the backstory. This site belongs to a very rich man who just inherited a large sum of money. His dream is to live out here with his 12 golden retrievers. So naturally, he's less worried about budgets or grading costs and more interested in a scenic driveway for weekend joyrides with his dogs. That's the project. Not exactly practical, but hey, it's perfect as a teaching example for young civil engineers. Before I start drawing the road line, I want to create some contour lines. Contour lines are a great way to visualize the terrain. I'm using 25-foot intervals, so I get a good sense of the terrain without making the map too busy. But it has also another purpose. This way I can keep the alignment within a reasonable elevation range when I draw the road line. Okay, it will take a few moments to create the contour lines, which gives me an opportunity to talk about something, and I think it's important and fundamental in developing this road. Now, the goal here is to draw an access road from the main road up to the pad. I'm going to follow the path of the existing road, so you can think of this as more of a road improvement project than a brand new layout. By staying close to what's already there, I can keep earthwork to a minimum and still get a usable alignment for the road. Keep in mind that you will have difficulty when drawing the line when the contour layer is turned on. The line would like to snap to these lines. To avoid that, just hold the Alt button on your keyboard. It will allow you to pick any point on the map. Notice I try to stay between 2 contour lines while following the existing road because I want to keep the road on level, so there won't be drastic changes on the vertical grade. By picking the alignment close to same elevation, I'm reducing the work that the code will process to a minimum. If I don't do this, the values can go out of whack during processing the data. This step is important, that you start with close to a realistic road alignment. Our employer might have deep pockets, but that doesn't mean we are not cost conscious and safe in building this road. I am almost finished with the first pass on the alignment. Don't worry about these sharp turns and tight curvatures, because the code will adjust the radius in accordance with your input, which will have speed, length of the vehicle, and vertical grade. Okay, I think I am done with sketching. This will serve as the preliminary center line of the road, but I can't use this line directly. It's too rough, too jagged, and it doesn't have the smooth curvatures a real road needs. Without horizontal and vertical geometry, it's basically a roller coaster track, and no vehicle is making it up here safely. Let's save this road into a separate layer, which I call Access Road Lines. Next, I'll select the road line I just drew so I can pull up the profile. This does 2 things for me. First, it shows the vertical alignment and how the grade changes along the route. That gives me an immediate sense of whether the slope is workable or way out of range. Second, I can export these values direct. Once I have them in Excel, I can run my code to smooth out the line and bring it in line with real road parameters like maximum grade, vehicle length, and pavement thickness. Now that the profile is ready, I want to export it as an XYZ file. But before I do that, I'll adjust this sampling interval to 10 feet. If I don't, Global Mapper will generate tens of thousands of rows, which is overkill for this step. And here's a tip. When you save the file, make sure to save it as a CSV instead of XYZ. That way you can open it directly in Excel and work with the data without any trouble. I've previously created another profile file, so I'm going to overwrite that. Let's bring in the CSV file and take a look at what's inside. And you will see it's pretty straightforward. Latitude, longitude, and elevation values in 3 columns. Now the next step is to bring in the macro code and run it. If you've never used a macro before, don't worry. It might not feel intuitive at first, but it's actually simple once you see it done. Here's how. Go to the View tab, find Macros, and click Record Macro. Then immediately stop the recording. This creates a macro entry that you can now edit. Open it and hit Edit, delete what's in there, and paste the code I provided, which you can download it using the link below this video. Once the code is ready, hit Run. It's the little play button. The macro will start asking for some input parameters. Just follow the descriptions on each one and enter your values. For this example, I'm keeping most of the defaults except for the grade. I'm setting that to 10%, which is typical for access or forestry roads. And I am defining the road thickness parameter as well. We are almost done with the inputs. Once they are in, the macro will run to adjust the road profile both horizontally and vertically. Essentially, you'll create a 3D polyline you can use to create the road surface. The macro has almost finished running, and it automatically corrects the road profile in the background. You'll see a completion message pop up. Once you do, just close the dialog box and exit out of the macro window. Before we move on, make sure to save and close the file. That part's important. If you leave it open, Global Mapper will throw an error when you try to upload the data. Next, I'm going to drag and drop the file straight into Global Mapper. The software will automatically recognize the CSV format and open a dialog box to match each column to the right field. Just take a second to double check that everything lines up correctly. Latitude, longitude, and elevation should each be mapped to the right columns. When the projection box opens, make sure you select the correct units, in this case, feet. If you skip this step or pick the wrong one, your elevations will look completely off. Next, we are going to create a buffer to our road center line. What the buffer does is pretty simple. It creates mirrored edges on both sides of the road's center line at a set distance. Since a typical lane width in the US is about 12 feet, I'll set the buffer to 12 feet, which gives us an overall road width of about 24 feet. That's more than enough for this type of road, even with some shoulder space from the cut and fill. And one more thing, make sure to select the rectangular boundary option instead of round. That'll give your road a clean, realistic edge instead of a bumpy outline. Now, I know what you're thinking. We went through all that hassle of exporting the data, running the macro, and re-importing it just to assign elevations to the road. But what if we didn't do that? What if we just took the raw line work, added elevation straight from the DEM, and tried to create the road design right away? Let's find out. I'll show you 2 wrong ways, basically what won't work, so you can see why those extra steps matter before generating a proper terrain surface. All right, first wrong way. This is when you use the Calculate Flatten Height that equalizes cut and fill volumes option. If you try this without assigning any elevation to the road, Global Mapper basically thinks the entire surface is one flat sheet from start to finish. So what it does is take the cut volumes from the higher end and spreads them over the lower elevations. And as you can see here, you end up with this really bizarre, unrealistic result that has nothing to do with how an actual road would behave. Let's take a look at it on 3D view. Yep, that's not how a road should look like. All right, I'm going to move on to the second wrong way to do this. In this case, I'm using a road surface that only has elevation assigned directly from the terrain. No processing through my code, no smoothing, nothing. It's basically just the raw line with a few horizontal curves added. Only this time, I'm going to select Flatten to Area Height, which, by the way, is the exact same option we'll use in the right method next. But let me show you how this version completely falls apart. You'll notice right away that not much changes. That's because the software just takes the surface and glues it directly to the terrain. So there's no real vertical component, no slope, no grading, no elevation control. What's happening here is that the ground isn't being reshaped to match any grade value. It just follows the natural terrain and flattens the road right on top. And of course, that's not how any real road behaves in the field. As you can see, the road looks almost non-existent and it's barely visible because the vertical component of the road is not processed. Now that you've seen how not to design a road, let's do it the right way. And honestly, it's pretty simple once you've processed the line with my code. So here's what I'm going to do. I'll pick the Calculate Flatten Area from the menu, same as before with the Flatten Area Height selection. But this time I'm using proper data. The road that already has elevation assigned, I'll set both the cut and fill slopes to 30 degrees. That's a good balance number for most terrain types and keeps things realistic. Once I hit OK, you'll notice the difference right away. The road blends smoothly with the ground, transitions are natural, and it actually looks like something you could drive on. And the best part, the cut and fill volumes are stored right in the feature attributes, so you can check them anytime without rerunning the analysis. And hey, if you like this video and want to know more about site designs with Global Mapper, check out this video on how to create the site pad under 5 minutes.